Mm-hmm. All right, so problem number 15. There, that one should work. If not, let me know. So I love that we are starting with this problem. This is actually one of the types of problems that we learned how to do at the beginning of this module. And I even told you guys at the time when we learned this particular theorem, I was really worried we weren't going to remember it back again at the end. So let's look through this problem. First of all, this angle right here, angle 3, is that inside or outside the triangle? Outside. What do we call angles that are outside the triangle? Exterior. That is an exterior angle. How big is this particular exterior angle? 2x plus 9 coming from right here. So I'm going to add that to my picture. 2x plus 9. These two angles, angles 1 and 2, are those also exterior angles? No, what do we call those? Interior. And very specifically, because they don't touch this exterior angle, we have another thing that we can add on to their name. They're not just interior angles. Does anybody remember what we add to that? They are interior, but they're a special kind of interior angle. Remote. These are remote interior angles. Angle number 1 is x minus 10. And angle number 2 is 3x minus 7. I cannot add angle 1 and angle 2 together and set it equal to 180. The only way I can take angles that are inside the triangle, add them together and equal it to 180 is if I have all three that are inside the triangle. I can't add angle 1, 2, and 3 together and set it equal to 180 because 2 of them are inside and 1 of them is outside. So what we do is we add the 2 remote interior angles. So I'm going to take the measure of angle 1 and add it to the measure of angle 2. I don't equal that to 180 because it's just 2 angles, but what can I equal it to? The exterior angle. In this case, that would be the measure of angle 3. These two angles together will always add up to my exterior angle. As long as the interior angles don't touch the outside angle, then they add up to that outside angle. All right, so now we're going to substitute in the place of the measure of angle 1, I have x minus 10. Then I drop my plus sign down. In the place of the measure of angle 2, we have 3x minus 7. Equal sign, and then the measure of angle 3, we have 2x plus 9. Now we're going to combine our like terms. X and 3x combines to give me what? 4x. And then negative 10 and negative 7 combines to give me negative 17. So I have 4x minus 17 equals 2x plus 9. Then we're going to get our x's on the same side. So I'm going to minus 2x from both sides. That gives me 2x minus 17 equals 9. Then I add 17 to both sides. What is 9 plus 17? 26. So 2x equals 26. And we divide both sides by 2. What is 26 cut in half? 13. So x is 13. Is that the only thing they asked me to find in this problem? No, it says find the value of x and what? Measure of angle 2. So I'm going to come over here. The measure of angle 2 equals 3x minus 7. So the measure of angle 2 is equal to 3 times 13 minus 7. What is 3 times 13? 39 minus 7. What is 39 minus 7? 32. So the measure of angle 2 is 32, and we're going to put degrees on that since it's an angle. Going to put a degrees marking on that since it is an angle. Yes?
I wrote all of that on the wrong problem.
Row.
On 14.
On 14, just draw an arrow. And then when you go to do number 14, just do the work for 14 down on the other one and draw an arrow. Or you can rewrite it, but I would just draw arrows personally. What else would you guys like to see?
1.
Number 1, absolutely. Let's go look at problem number 1, front page. All right. So I'm going to start with this given information up here. It says angle ABC is congruent to angle ABD. So A, B, C. This is angle ABC right here. And then A, B, D. This is angle ABD over here. So my first piece of given information tells me that these two angles down here are congruent to each other. And then my second piece of given information right here says angle CAB, CAB, this little angle up here, is congruent to angle DAB, this other little angle up at the top. Let me draw that in a little bit better. There we go. So I have these two angles down here and these two angles up here are congruent. That's my given. What other piece of information do you know from the picture? So there are two things that I said you are always allowed to mark on the picture, even though it's not part of the given information. What are the two things that we're constantly looking for that we're always allowed to mark no matter what? Shared sides and vertical angles. Do we have either of those situations here? I have a shared side. What is the name of the shared side in this picture? AB. So let's mark it with a congruence marking. And over here on the line, I'm going to write that segment AB is congruent to segment AB. It is congruent to itself. We are always, always, always allowed to mark vertical angles and shared sides. In fact, those will almost never be marked up for you already. You have the responsibility to go in and look for those two pieces and mark them up on the picture. Do we have enough marked up here to say that these two triangles are congruent? Yes. So let's write the triangle congruence statement, and then we will name what we are using to say these two triangles are congruent. The first triangle that we name, we can name it any way we want to. The order does not matter at all for the first triangle. So, I don't know, just to make it easier on ourselves, let's look at the yellow one here. Give me one way to name that yellow triangle. ABC sounds good. We could call it triangle ABC. You can do the first triangle in any order. Second triangle name though, now we have to make sure that we are matching up our corresponding congruent pieces. So I want to look at the way the picture is marked up and make sure that I'm matching pieces up. So angle A on the yellow triangle is this one over here, and it has the two congruence markings on it. What does that correspond to on the white triangle? Angle A, so I would start this with A as well. Angle B on the yellow triangle has this one blue congruence marking on it right here. What does that correspond to on the other triangle? B. And then finally we get to C that has no congruence markings on it. And what does that correspond to? D. So triangle ABC is congruent to triangle ABD. When it says what postulate or theorem are we using, when we're showing two triangles congruent, that means we could do side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Which one of those is getting used in this picture? Angle, side, angle, yes. This is angle, side, angle. If we actually wanted to use angle, angle, side, I would need to know about a different pair of angles being congruent. So right now, when I look at angle, side, angle, I go find my side right here. Angle, side, angle has both of the angles on either end marked. Angle, angle, side has one angle that touches my segment and one angle that doesn't touch my segment. So what other pairs of angles would I need to be congruent if I was going to use angle, angle, side? C and D. I would need that angle C is congruent to angle D. Nicely done. What else would you guys like to see from the review? 17, absolutely. Let's go look at problem number 17. For problem number 17, we have a triangle congruence statement up here. And we are going to use that to match up our corresponding congruent angles and our corresponding congruent sides. For the angles, I want just a single letter. So I'm looking at this first triangle name, and it has A, so I would say angle A is congruent to. First letter in the first triangle name corresponds to the first letter in the second triangle name. So angle A is congruent to angle S. And then I'm going to continue to match up the position of the letters. What would be another pair of angles, according to this congruence statement, that are congruent? W, second letter, would correspond to what? O, second letter. Angle W is congruent to angle O. All right. I have a third pair of angles, E and M, third letter and third letter. Angle E is congruent to angle M. Perfect. All right, now we want to do our sides. Do we use just one letter for sides? How many letters do we need for sides? 2. So instead of looking first letter to first letter, I'm going to look at first 2 letters and first 2 letters. So I would say segment AW is congruent to segment SO. First 2 letters, first 2 letters. What else could I match up? WE, middle and last letter. O and M, middle and last letter. WE is congruent to OM. Perfect. But now I got to the end of the triangle name, but there's still one more side. How do I get the last side? I did the first and second letter. I did the second and third letter. AE, first and third. AE is congruent to, what would AE be congruent to? SM, first and third. All right, then we get over here to this question over on the right. It says, what is the reason that these parts are congruent? They gave us a clue right there. Parts, P, congruent, C. Yes, corresponding parts of congruent triangles are congruent. These are all corresponding parts. These are my corresponding angles and corresponding sides, so they are corresponding parts. I had a clue right here. The two triangles are congruent. They gave me a congruent statement right here. And so the parts are also congruent. What else would you guys like to see? Number 2, absolutely. Problem number 2. Let's go through the given information first. What does this upside down capital T mean that's in between these letters here and here? Perpendicular. And what does perpendicular mean? When you see perpendicular, what do we draw on the picture? Right angles. We're going to look at where those lines come together and touch. So AB, oops, that's not AB, AB right here, and AD right here. So this corner where A is a right angle. And then it says BC, that's this, is perpendicular to DC right here. So right at C is my other right angle. And then it also says that segment AB, right up here, is congruent to segment DC, right down here. There's another piece that we know and we are allowed to mark on the picture. What are we allowed to mark? The shared side. What is the name of my shared side this time? DB. So let's mark it on the picture. And I'm going to say DB is congruent to DB. Are these two triangles congruent? Yes. Let's look at what we have marked up. Let's write our triangle congruent statement and then we'll write the reason. So we're going to look at our markings to get our triangle congruent statement written. And then we're going to name the reason for this. So first triangle, let's do the yellow one. What do you want to call that one? ABD, sounds good. Remember, first triangle you name however you want to. ABD. Second triangle, we have to make sure to match up the corresponding pieces. Angle A is my right angle up here. On the white triangle, what does that correspond to? C. So I would start this with C. And now none of my other angles are marked here. So I got to use a different way of figuring this out. The first two letters here were AB. When I look at segment AB, it has a congruence marking on it. What does that correspond to on the other triangle? CD. Thank you. We already know that C has to start because it corresponds to A. So then D has to be in the middle. So then what would have to come last? B. Triangle ABD is congruent to triangle CDB. Now let's look for our reason. When I just look at what's marked on the picture, I see an angle right here. I see a side right here. and then see another side right here. Can I use angle side side? No, please don't write that down. I had somebody do that on skills check yesterday. I was very sad. Insulting things from students on skills checks. So I can't use angle side side, but the triangles are congruent. What kind of triangles are both of these? What kind of triangles are we looking at? Right triangles. There was one of the reasons that we were allowed to use that only works with right triangles, which was HL. But we got to make sure that that works here. How do you find the hypotenuse on a right triangle? How do you find the hypotenuse on a right triangle? How do you locate the hypotenuse on a right triangle? It is unbelievably important for second semester that we learn how to identify the hypotenuse of a right triangle. What am I looking for when I want to find the hypotenuse? Yes. We find our 90-degree angle. So I'm looking right here. And then in relationship to that 90-degree angle, where's the hypotenuse located? Opposite side. So here's my right angle. This is the side that is opposite that right angle. So this is the hypotenuse. When I look at the other triangle, the white one, the right angle is right here. Here's the side that is opposite that right angle. So DB is the hypotenuse of both of my triangles. And then we have another side that's marked. What do we call the other two sides on right triangles? Legs. So this is a leg up here, and this is a leg down here. The hypotenuse of both triangles are congruent because it's congruent to itself. And the two legs are congruent, AB and DC. So we are going to use HL, hypotenuse leg. Just because it's a right triangle does not mean it's HL. But if it's a right triangle, it can be HL. Make sure you know how to identify the hypotenuse. What else would you guys like to see? 16, absolutely. Problem number 16. Given the following diagram, it says that AB and DE are, what's the two vertical lines mean? Parallel. Well, when we see parallel, in this module, I've told you to draw what when you see parallel? Draw a Z. I'm going to keep that in the back of my mind. But I think I'm probably going to have to draw a Z because we saw parallel lines. It says C bisects both segment AE and BD. What does bisect mean? Cut in half. So let's look at what's being cut in half. It says AE is being cut in half. Oops, right here. Right at C. So what are the things that I could mark as congruent if AE is being cut in half at C? What could I mark as congruent if AE is being bisected at C? Yes, AC and EC. This right here is congruent to this. But then it also said that C bisects BD. So this is also being cut in half at C. So what else can I mark as congruent? Yes. BC, this right here, I'm going to put 2 congruence markings on it, and CD right here. So far, so good? We said we had parallel lines, so I can draw a Z. I have to go on top of the parallel things, so AB was one of the parallel things, and DE was the other parallel thing. If I want to make a Z-type shape, how many options do I have to connect these two to make a Z shape? How many options do I have? If I want to connect this purple line and this purple line to make a Z-type shape, I have 2 options. I can connect them like this to make a Z, or I can connect them like this to make a backwards Z, but it still has that Z-type shape to it. If I connect them like this, where are my congruent angles? If I connect them like this, where are my congruent angles? Yes, ABC, this angle right here, and CDE, this angle right here. Notice I'm connecting purple to purple in the corners. Oops, too much. All right. So I've got a pair of angles marked as congruent. But we said we could do our Z the other way. So I could also draw a Z like this, and that lets me find another pair of congruent angles. Where would the congruent angles be now? A and E, angle BAC right here, and angle CED down here. That's a lot of information from my given. Is there anything on the picture that I'm allowed to mark even though it wasn't given? Vertical angles. Where are the vertical angles located? Around what letter? C. That's where my X is. So this angle is congruent to this angle. All right, let's look at the statements down here. Could I use side angle side to show these 2 triangles are congruent? Could I use side angle side? Sorry, let me highlight my triangles here. Here's one triangle. Here's the other triangle. Don't pay attention to any of the rest of the lines here. We are just focused on the yellow and the pink triangle. Could we use side angle side to show these 2 triangles congruent? Yes, side, angle, side. If I look at the other triangle, I have side, angle, side. So I can use side, angle, side here. So I'm going to put a check. Statement 1 is correct. Because I know statement 1 is correct, which of these options can I get rid of? D. I know it can't be that one because that says it's only statement 4, and I know statement 1 works. All right, let's look at the second statement. It says the 2 triangles are congruent by angle, side, angle. Could I use angle, side, angle here? Yes, I could do angle, side, angle, or I could even do angle, side, angle. So I can definitely do angle, side, angle here. So we're going to put another check mark, which means I can get rid of what other option? A. It's not just statement 1, so I can get rid of that one. The triangles are congruent by side, side, side. Do I have side, side, side? I only have two sides. I don't have that ED is congruent to AB. So this one does not work. And then option 4 says the triangles are not congruent, which is also not true. So what is my correct answer here then? B. Because it's not option 3. All right. We have about 13 minutes left. That's enough time for probably right around 3 more problems, depending on how long they are. What else would you guys like to see? Number 3. Absolutely. Back to the front page. For the triangles to be proven congruent by side, side, side. Well, we already have these two sides marked as congruent. And we already have these two sides marked as congruent. What else would I need if I was going to use side, side, side? GE is congruent to LD. Let's mark it on the picture. GE is congruent to LD. Write a congruence statement for the two triangles. So this is going to be tricky. When I write my triangle congruence statements, I love it when the angles are marked as congruent because that lets me match up my letters a whole lot easier. When it's just the sides that are marked as congruent, it gets a little trickier. It's still possible. Let's name this yellow triangle, the one on the left, first, because order doesn't matter on my first triangle. What do you want to call the first one? What could we call the first triangle, the yellow one? GEO, sounds good. So triangle GEO is congruent to, okay, gotta be careful here. G, the first letter here, if I go look at G, that's where my side that I marked with purple touches the side that has 3 congruence marks on it. What does that correspond to on the other triangle? D. Purple meets the side that has 3 congruence marks on it. So G and D are corresponding. So that means I need D right at the beginning. All right. And then it was GE. Well, GE is the side that has 3 congruence markings on it. What does that correspond to on the other triangle? Yes, DL right here. This side has 3 congruence markings on it. I already have D written down, so that means I need L as my second letter. D corresponds to G, and GE corresponds to DL. So this would be DL what? DLO. For the triangles to be congruent by side, angle, side, name the additional part that needs to be congruent. Well, I could do G congruent to D or E congruent to L, but I'm not allowed to mark those without being told. There is one pair of angles that I'm allowed to mark up here, even though it wasn't already marked on the picture for me. What angles am I allowed to mark as being congruent, even though it wasn't already marked on the picture? I don't have a shared side, but you're on the right track. Vertical angles. I have vertical angles here. The vertical angles are centered around what? O. So I have this angle here, congruent to this angle here. What could I name this angle? Give me a 3-letter name for this angle. GOE. Angle GOE. I can't just say angle O, because angle O congruent to angle O sounds like I'm talking about one angle, and I'm talking about two. I have to separate them. What could I call this angle over here? What could we call this angle right here? DOL or LOD. DOL or LOD. Angle DOL, or again, you could flip the first and third letter around, angle LOD, but O has to be in the middle. All right, what else would you guys like to see? 10? Absolutely. Problem number 10. In triangle BRK, the measure of angle K is 7 less than 3 times the measure of angle B. The measure of angle R is 30 degrees. Find the measures of angle K and angle B, then classify the triangle by its angles and sides. All right, so K is 7 less than, so that means minus 7 from 3 times the measure of angle B. Well, when I see 3 times, that means to multiply by 3. Do we know how big the measure of angle B is? So what can I call this one? X. So let's say the measure of angle B is X degrees. That means the measure of angle K would be what? We do have a negative 7, but I need to subtract 7 from this, 3 times the measure of angle B. So what would that look like? We are going to have a minus 7. It's going to come at the back. How do I do 3 times the measure of angle B? 3x. 3 times the measure of angle B, 3x, and then we take 7 away from that. And then it also says that the measure of angle R is 30 degrees. Measure of angle R is 30 degrees. What do I want to do with these 3 measurements now? What do I want to do with the 3 measurements? Add them up and equal them to 180. I need you to sit up for me, please. Measurement of angle B plus the measurement of angle R plus the measurement of angle K equals 180. In the place of B, we're going to put X. Plus, in the place of angle R, we're going to put 30. Plus, in the place of angle K, we put 3x minus 7. We equal that all to 180. Combining like terms. What do I get when I combine my x's? 4x. What do I get when I combine my constants? 23. So I have 4x plus 23 equals 180. Then what do we do? Subtract 23 from both sides. What is 180 minus 23? 157. So I have 4x equals 157. Then I divide both sides by 4. Does this come out to be a whole number? No. Does that mean that we made a mistake? Also no. What do we get when we divide this? 39.25. X equals 39.25. 39.25. So how big is angle B? Yep, 39.25 degrees. To find the measurement of angle K, we do 3 times 39.25 minus 7. What is 3 times 39.25 minus 7? 110.75. And now we're going to classify this triangle. We want to classify it based on its sides and its angles. Are any of the angles the same size? No. If none of the angles are the same, then none of the sides are the same. What do we call a triangle where none of the sides are the same? Scalene. We also have to classify it based on its angles, obtuse, acute, or right. Is this a right triangle? How do we know? Yep, none of the angles are 90 degrees. Is this an obtuse triangle? Yes. How do we know? Yes. More than 90 degrees, so that means it is obtuse. So we would say this is an obtuse scalene triangle. Obtuse scalene triangle. All right. We are only 1 minute from the bell, so unfortunately I do not have time for any more questions. The answer key for this test review is posted in Canvas. I've showed you guys where that is many, many times in the past, but if you don't know where that's located, please let me know. I am happy to show you where the answer key is. You will be turning in this test review tomorrow when you come in to take your test. Please send me messages through Canvas if you have any questions. Also, the videos from all 4 of my sections will be posted. Every class asks about different questions, so it can be helpful to go check out the video from a class period that you are not enrolled in.